Hello, everyone, and welcome to another mini sky tonight. So continuing on with our Moons of the Solar System tour, we're looking at the two moons of the other terrestrial planet that does indeed have moons, Mars. And those two moons are Phobos and Deimos. So let's dive into these weird, odd moons that may have been captured, may have been not. So they're named after the Roman gods of fear and panic because, well, around Mars being the god of war, you often get fear and panic. So there was often these two little entities that followed around with the god of the underworld or the god of war. So you kind of can see pain and panic in the Disney movie Hercules, and that's kind of what they represent, but it's the traditional fear and panic. They were first discovered by Asaph Hall in 1877 at the new U.S. Naval Observatory. So even here in the United States, we're discovering unique, different things. They were first observed by Galileo Galilei, but he wasn't quite sure what they are because they looked like little bumps right next to Mars. And one time he thought, oh, it's just a star in the sky, but he wasn't quite sure. And Kepler, when he was reading a bit of Galileo's translation of what he discovered, he misinterpreted his text, which was originally in Latin, and translated it to meaning twins. So he thought these were the twins of Mars rather than the bumps of Mars, and he's hence the idea that there was possibly two. Well, it turns out they were ironically correct in both ways because the misinterpretation turned out to be that there are indeed two moons of Mars. So just to give you a rough idea how difficult it was and why it took so long, even from Galileo's time until 1877 to discover them, they're very tiny. Just to give you a rough idea in terms of the shape, one is 27 kilometers in one dimension, and the other one is about 12.6 kilometers in another direction, just for both moons. They're really tiny. I mean, they could fit inside the United States, they're that tiny. And their orbits are really fast, so to be able to catch them at just the right time is incredibly difficult. One has an orbit of 7.6 hours, and the other one has an orbit of 30.3 hours. So, and I'm doing it based upon the numbers on the top are for Phobos, and the bottom numbers are for Deimos. Both are tidally locked, meaning that usually one face of the particular moon faces Mars at all times. It's usually not until we're able to have different satellites, like we have the Mars Reconnaissance Orbiter and several other satellites that are in orbit around Mars, that we have been able to take pictures of the other sides of the moons. Now, given the distances that they are from the planet, Phobos gets a total lunar eclipse every night. Since it rotates, or it revolves around Mars so fast, roughly about 7.6 hours, every 7.6 hours, it eventually goes into the shadow of Mars. So unlike the Earth, which we don't get a lunar eclipse every month, on Mars, you get a lunar eclipse every night. But keep in mind, they're tiny. I mean, if you were to compare Phobos, it would appear 1/3 the size of the moon in our sky. So it's even smaller. And of course, if you look at Deimos, it's like 1/12 the size. And here's kind of like an image that was taken from Opportunity, where they took a bunch of different shots of zooming in towards the two moons in the sky, and this is how tiny they are. And this is zoomed in, mind that. So they're kind of relatively tiny in terms of moons. So a little bit of the surface and geology and why we're not sure what these moons are. They're similar to C-type asteroids or carbonaceous, so they don't even have any types of materials that are very similar to the planet that they orbit. Whereas in most moons, even around the gas giant planets, have kind of similar materials and makeup that are similar to the planet that they orbit, and or types of materials similar to that region, these aren't. Mars has a unique, different type of material on its surface, mostly iron. These mostly contain carbon. So many astronomers believe that these were possibly capsuroid. And they're irregular shape and they have a lot of craters on them, where Phobos has one of the biggest craters. The streaks that you see on the surface of Phobos is possibly indicators of landslides, like that the material on that during the impact of this particular crater was able to heat up, say, frozen ice water, and then it created a little bit of a landslide, so to say. But we don't know if they're captured asteroids, and the reason why has to deal with their orbits. They're nearly circular. In order to have nearly circular orbits, they have to be formed around about the same time the planet is. Very few objects that have circular orbits are captured that way. Most captured objects usually have very elliptical orbits, whereas in Phobos and Deimos have close to circular orbits. So astronomers believe that maybe it was captured during the early formations of Mars. So they were just stragglers that were, who knows, maybe could have made its way into the inner solar system to hit the Earth, and Mars captured them and claimed them as their own. We don't know. Some of the other features of it is that sometimes you get solar eclipses, but they're not as grand as, say, solar eclipses here on Earth, because our moon is just the right size and at the right distance to the Earth to where it can cover up the sun. Whereas in Phobos and Deimos, they're not as big. So the top one is Deimos, and the bottom one is Phobos. So you can see they do indeed cover up the sun for an eclipse, but not as grand as the eclipses we see here on Earth. In terms of other features, they noticed it had a very low density, even for carbonaceous asteroids. The density of most rocks is usually roughly around about 3 grams per cubic centimeter. The density of the rocks is 1.7. So these particular moons have a density much less than normal rocks. So they thought, well, maybe instead of a solid rock, it could have reservoirs of ice. It could be porous, maybe? We don't know. Also, another unique feature that I always thought was really cool is that Phobos, because of its fast rotation, rises in the west and sets in the east, because it just goes around Mars so quickly. And the Deimos goes from the east to the west because it orbits so slowly. Whereas in the orbit of Phobos is so quick, it literally looks like it's zipping by the sky. So, have we visited these two moons? Now, obviously, we've sent many probes and things to Mars itself, but not a lot of things to the moons themselves, because we always thought, oh, they're just captured asteroids. They're not as interesting, per se, as the planet itself, which we are hoping to put people on the surface of Mars. Now, the moons, however, may hold an interesting story, because many astronomers believe that, okay, if these were captured asteroids, maybe they hold key secrets to the early formations of the solar system, and maybe they can explain why the density is much lower. Perhaps they can find evidence for other types of materials that may have existed during the early formations of the solar system. So in terms of the satellites that have visited Mars and taken pictures of Phobos, Mariner 7, 9, Viking 1, and Phobos 1 and 2 have all taken pictures. But Phobos 1 failed in early launch, but Phobos 2 was able to make a successful trip where it took 37 images of the surface of these two moons. And of course, Mars Global Surveyor was able to take several images of the moons from orbit around Mars. Phobos Grunt was the first proposed mission with China and Russia to be able to send something to the surface of Phobos to take some samples. Especially they were interested in the area of the landslide, like what could have created this landslide. It was a failure because they had a lot of technical issues, but they're hoping in the future that they could possibly create another one to send in to Phobos. These are proposed future missions. So the idea of being able to go to these 2 moons and check them out is not off the table. Many people have wanted to, but have had to give up these proposals in the hopes of doing other missions. Like one in particular, the Aladdin mission was given up for being able to send a spacecraft to Mercury, the messenger. So it was basically a lot of give and take between different teams. So yeah, they couldn't do the Aladdin mission, but they were able to do the messenger mission to Mercury. So hopefully in the future, they may pick it up again, as well as Prime and OSIRIS-REx 2. Currently, OSIRIS-REx 1 is in orbit around different asteroids and trying to study them. So maybe they can send a second one to do sample returns of what these quote-unquote asteroids are. And of course, you have the Phobos Surveyor and Padme, which is Phobos and Deimos Mars environment, which hopefully it can basically study these 2 moons and how it affects Mars in a different way. Like what are the tidal forces and how does these small little moons affect the landscape of Mars? Because the moon does affect us here on Earth with tidal forces and other things as well. Does Phobos and Deimos affect the surface of Mars? And of course, where can you see Mars? I mean, obviously you can't really see these 2 moons, but you can see the planet Mars. In fact, currently in the sky, roughly around about July, you should be able to see Mars and Venus really close in the sky. So if you look towards the western horizon, roughly around about July 12th, you should be able to see these 2 planets really close in the sky, in the early evening sky, right next to the moon. So if you want to check out a planetary conjunction around about this time of year, head outside roughly around about July 12th and look towards the horizon. So these are the 2 moons of Phobos and Deimos, and the 2 moons of Mars. So if you have any questions, leave it down in the comments below. If there's a topic you would love for me to cover over, leave it down in the comments as well. And until next time, stay safe, stay healthy, and as always, never stop learning.